Okay, today we're working on section 6.2, multiplying and dividing radicals, and we'll go through this. All right, just a quick review of where we've been. So on this particular problem, there's a couple different ways we can do this one. The way that students did in class is they like to distribute the exponent to everything first. So that means I got 2 to the 4th, x to the negative 8th, and y to the 12th. 2 to the 4th, 2 times 2 is 4, times 4 is 8, times 2 is 8, times that, so that's 16. X to the negative 8th is going to go down to the bottom. Y to the 12th stays in the top. So that's how people have been doing that. That's a fine way of doing it. The next one, okay, we're looking for what perfect square times some other number is 75. Well, that ends up to be 25 times 3. Now, x to the 4th, the index here is 2, so I want it biggest even I can take out, and I'll leave just 1 over there. Simplify this. The square root of 25 is 5. The square root of x to the 4th is x to the 2nd. And then I got 3x. And now for the new material. What we're going to have here new is when I combine these, when I multiply these, and now we've been using this fact, when I multiply these, as long as they have the same index, I just multiply the numbers. Now, an example of this has been I just got done with this problem, is this. Square root of 25 times square root of 3 is the square root of 75. We did it the other way, but these are both the same thing. So we've been using this quite a bit, so it's not too bad. The important thing is the index. This n must be the same. If it's not the same, then I can't do it. Now, I can multiply it and then simplify, or I could simplify first. I typically multiply first and then simplify it. So in this case, I can't simplify this out, so I'm going to multiply it. I get the 4th root of 2 times 8 is 16. Now, the 4th root of 16 is just 2. This one, I can't do it. See how this has a 3 and this has a 4? This one cannot be done, so that's my answer. Nothing I can do to that one. On this particular problem, there's a couple different ways you can do this. All right, now I could simplify this first, and that's kind of how they have this set up. Now on smaller numbers, you can do them, multiply them together, and then simplify. Bigger numbers, maybe it's better off to do that way. Let's do this one this way. So I can take x squared and y to the 4th out here, and the 10 is, there isn't a perfect square that goes in the 10. So these are what I'm left with. So if I just finish this off, I get x, y to the 2nd times square root of 10, x, y. Now let's do the other one. 8 can be broken down as a 4 and 2. Let's take an x squared and a y squared out, left with a y. So this is 2xy times square root of 2y. Now what I would do is I just multiply these two things. The 2 has nothing to multiply by. I have x times x, so that's x squared. Y squared times y is y to the 3rd. And I can multiply those numbers here. And then when I multiply those numbers, I get 20xy squared. Now, this is going to start showing you why I don't prefer this way. So 2x squared y to the 3rd. I can break 20 down as 4 times 5. The x stays here. The y squared goes here. So I got 2x squared y to the 3rd times 2y times 5x. And that's equal to 4x to the 2nd, y to the 4th times square root of 5x. Now let's go through and do this in a different method, just so that you can chance to see this done a little differently. What happens if I just multiply these? I get 80 x to the 5th, y to the 8th. 80 is 16 times 5. Take out x to the 4th and y to the 8th. I'm left with just an x here. 4x squared y to the 4th root 5x. And notice I get the same answer. Now, there are some that will be easier to do if you just multiply them out. Some that will be easier to do when you simplify them as you do them before you do the multiplication. I really can't tell you which way to do them one way or the other way. I will tell you that I prefer to do it the way in the red. I prefer to multiply it out and then simplify down next. But that doesn't mean that that's necessarily the best way. It's just the way I prefer to do it. Complicated problem right there. Now, what happens if we have a division problem? Well, division problems, if I have the square root and the square root, both of them having the same index of two numbers, well, I can rewrite that as a fraction. The nth root of a divided by b. So let's look at this one. Now, again, you can do this one at a time, one thing at one, either top at a time or the bottom at a time. But I prefer to look at this. They both have the same index. So this is the square root of 18x to the 5th over 2x to the third, excuse me. Well, now I'm going to reduce this fraction. What goes into both 2 and 18? Well, 9 does. And where are there more x's? There are more x's in the top. So I got the square root of 9x. Square root of 9 is 3. Square root of x squared is x. So that's what that would work out to be. And I prefer to do it this way than any other way. It just kind of makes it easier for me to do this. Rationalizing the denominator is kind of challenging, and especially as it gets a little bit more complicated. With this one, what I'm trying to do is I want to take it to the next perfect. So I want to get to the next perfect square, perfect cube, or whatever. The easiest way to do that, especially with squares, is to multiply by itself. With cubes, it's to multiply by its square, and so forth up there. So I don't multiply both the top and bottom. I'm multiplying it by 1 because the square root of 2x divided by the square root of 2x is 1. So when I do this, I multiply those underneath there, so I get 10x. Over here, I get the square root of 4x squared. Well, the square root of 4 is 2, and square root of x squared is x, so I got 2x, and then on top of it, 10x, the square root of 10x. All right, now that shows just the benefit of taking up to the next perfect square. This one's cubed. All right, so I want to take 2 cubed is 8. So I need to multiply this to get it up to 8. So I'm going to multiply by the third root of 4 and the third root of 4. So this is the third root of 8, and this is the third root of 4x. Well, the third root of 8 is 2, and I don't know what the third root of 4x is. These get a little bit more complicated. We won't see too many of these, but they definitely get a little more complicated. And that's it. Your assignment. This is actually the assignment on Canvas. There are a lot of problems there, but you only have to do the odds here. Okay? Have yourself a good evening.